And up next, we have our R portion, which is, my favorite because I did the R portion last year. But we have Lucy D'Agostino McGowan here with us to present the R portion of the Data Jamboree. Lucy is an assistant professor in the Department of Statistical Sciences at Wake Forest University. She received her PhD in biostatistics from Vanderbilt University and completed a postdoctoral training at Johns Hopkins University Bloomberg School of Public Health. Her research focuses on analytic design theory, statistical communication, causal inference, and data science pedagogy. Dr. D'Agostino McGowan is the 2023 chair of the American Statistical Association section on statistical graphics and can also be found blogging at livefree or dichotomize.com, on Twitter at Lucy Stats, and podcasting on the American Journal of Epidemiology partner podcast, Casual Inference. Thank you very much for being here today, Lucy.
Sam, happy to be here. So I wanted to first just share where you can find the code that I'm going to be using. And so if you go to my website, you can go, it's lucymcgowan.com /talk. You can see the first one is going to be the Data Jamboree from today. And if you click on this details link, it will take you to a GitHub where all of the code for today can be found. So I wanted to put it in the chat, and for great, if possible.
Oh, Lucy, we lost you for a second there.
Oh, can you hear me now? Am I
Yes.
still? Okay. Well, I wonder if I was just saying, I was hoping to put this link in the chat, but I lost the chat window when I made my screen full screen. So if you don't mind.
No, okay. I'll put it there for you. No worries.
Okay, thank you. Awesome. Great. So, all right. So yes, I'm going to be doing the R version. So let me I split it into 3 different notebooks for data cleaning, data manipulation, and data analysis. And so some of this I'm going to sort of walk through live because I think it's a little bit easier for me to slow down and go through it if I'm going through it live. And then some of it I'm just going to show you the code that took a little bit longer to run. I'll show you what the output is. So you've all seen this twice, and so you're familiar with the data and with the question. I'm just going to highlight a couple things that are nice that R offers for data cleaning first. So I'm going to load a couple packages. The ones that I'm going to be using the most really for this first part are tidyverse, which I'm going to use to let me read in my data and do a little bit of manipulation. And then I'm using this point blank package to be able to do a little bit of exploration of my variables and also just to sort of get a sense of if there's any kind of irregularity in the data. So the first thing I always do when I'm reading in a large CSV is I usually will just run the read CSV as is without kind of doing any other, let me make my screen just a slight bit bigger, without any other changes to it. So I'll show you what that does. It reads it in like this, and it gives me, by default, I get this little message. So I see that there was a warning message, and then I also see the column specifications. So it gives me this note that I can use spec to retrieve the full column specifications. And in this case, because there's so many columns, and I sort of trust R to determine what some of those column specifications should be, but I also want to make a couple updates. I find this really, this spec function really very useful. So I can run that on this, so just spec and then the name of my data, which in my case is data. And oops, let's see, did I do this already? Oh, I think I did. Usually this is going to work. Hold on. This is the problem with the live coding. Maybe I should have just let this, let's see. What am I doing here? Okay. It's telling me some problems that it still should be able to tell me data equals data. Okay. Something. So typically what this will give you is this nice little output here of all the different columns that I can then paste in. And so it gives you this kind of calls exactly what I've pasted here. And it puts what it guessed all of the different columns were But what ended up happening here that I updated where there were two, this created date time, I wanted to change that to a date time format, and I wanted to specify what that date time format was based on what I knew about this particular data set, and the same for the closed date here. And then another one that I wanted to change down here, it was having some trouble with this taxi pickup location, and so I decided to read that in as well, using this call character to tell it that I wanted it to be a character variable. All right. So then the next piece is going to do a little data cleaning. This looks a lot like what Shannon did in Python, where I'm just going to replace, I want to take all of the column names and I want to rename them by replacing any dots with, or any spaces rather, with underscores. And then I want to have it be two lower. So I want everything to be lowercase. So that will clean up my names. All right, so this next part, this scan data and this export report, these are functions that come from Point Blank, which is this nice package that basically allows you to look at kind of what's going on with your data. So this very first, I just ran scan data and then export report. And it creates this nice report where I can see an overview. So first of all, it tells me some meta details like the number of columns, 41, the number of rows. It also gives me what those variables are. It tells me how many missing values there are for each of them. And it gives me some other details like the minimum and maximum. And so this is helpful to be able to just get kind of a high level scan of my data. If I want to see more details, I can click on this toggle details and it will tell me, for example, what the most common values are by frequency. So I can see like for this cross street 2, most of those are missing. We have like 35% missingness and then about 1% are on 2nd Avenue and so on. So this is a nice way to be able to sort of dive into a large data set without having to run a whole bunch of different functions. It's just a nice way to kind of visualize it, and it also gives me this little picture on the bottom that tells me about what my missing values are, which also, if we looked at this a little bit more closely, we could see that there's several variables where almost all of the values are missing. And then the next part that this is also from Point Blank, you can do these validations. So the Point Blank package, it's the terminology for the functions are all sort of like secret agent themed, but the idea is that you take your data and then you create an agent and then you do several validations. So for example, this first one, I'm checking that unique key that, that everybody has a unique key. So nobody has a null value for those. And then I'm also making sure that all of those unique keys are actually distinct. So you would expect the unique key to be unique for everyone. So we can check that. I have a couple other little validations that I'm doing here. This first is I'm checking that the created date is checking whether the created date was less than the closed date. And then I'm also checking whether it was less than or equal to the closed date. So the less than or equal to would be like if if the ticket closed exactly when it was created, and then the former would be sort of something that as you would expect that it was created before it was closed. And then I'm going to check a couple other things. So you can add as many checks as you would expect for the types of variables that you know are in your data set. For example, I knew that I had latitude and longitude, and we know like what you would traditionally think the values of latitude and longitude should be. So I could check that all of my latitude values fell between those reasonable values, and all of my longitude values fell between those reasonable values as well. And then these little NA passes are just saying that if the value is missing, we should treat it as passing in this particular case. And so this gives me this nice kind of interactive output where I see each of my different checks here. So these are the different steps. These are the columns that were affected by that step. This is the expectation for what the value would be. And then these checks indicate whether they passed or not. And so I can see that you can set different values for what you would consider passing or not passing. I can see here that, like, for example, these two, so this is the column values less than and the column values less than or equal. I can see that 97% passed and 3% didn't pass for this less than one. So that indicates that like 3% of my observations had unusual create and close dates where it looks like the close date actually preceded the created date. The other nice thing you can do with the point blank validation is you can actually, it creates these little CSV files where you can investigate where certain fails actually happened. And so you can identify like where the fail points were. So if there were particular observations where something unusual happened, you can examine those CSV files and sort of see if there's a pattern that you recognize. All right, so then this next part, we were asked to sort of fill in, for example, if incident zip code was missing, but location was not, to fill that in. And so I just wrote, there are probably ways to do this. Using like other APIs and things. There are several packages. GGMap is one that you can reverse geocode, but I just wrote my own function to do it. This is this photoncommute.io. This is a link to something from the Open Maps, their API, but you don't have to have any kind of credentialing to use this. So you don't need a key or anything like that, an API key, which is kind of nice. So I wrote this function that took two arguments, the latitude and the longitude. Glue is a lovely package in R as well that lets you sort of deal with strings. And so I can create these different links depending on the latitude and longitude that I'm observing for these observations that were missing zip code. So I made all these different URLs, and then I can use the HTTR package to query that URL and get a nice JSON file. In this case, there is a property within that file that's called postcode, and so that's what I used to fill in my missing zip codes. All right, so summarizing my suggestions, several of the columns did have greater than 90% missingness, and so I listed those here. So those would be ones that I probably would not use in my prediction model going forward. All right, and then I went ahead and only included, I filtered out any of the created dates that happened after the close dates. All right, so now onto the data manipulation. I am using, again, the tidyverse for this and a couple other packages that I'll point out as I go through here as well. We were asked to focus on only requests made by NYPD, so I'm just going to filter that. We were asked to create a couple of variables, so a new duration variable. So I did that here. The mutate function is from the tidyverse, which is how we can make new variables. I'm also using Lubridate, so that's one of the other packages I loaded. Lubridate is a nice package for dealing with date times, so that's what I'm doing there. I created a new variable called, or a new dataset rather, called NYPD uncensored for this next part. So we were first looking at ways to visualize the distribution of uncensored duration by whether it was a weekday or a weekend. So the first way I decided to try to visualize this was with a mirrored histogram. These mirrored histograms, this is an add-on, it's a function that works with ggplot, GeoMirror histogram, but it comes in the half moon package, which is a package typically used for checking balance between groups if you're doing some kind of like weighting or matching or something like this, but it works nicely for this as well. I like the mirrored histograms because you can kind of easily compare the individual bins, which make it maybe easier to compare the distribution between two groups. I also used the ridge plots. So this comes from GG ridges. And so this is just, again, looking at those histograms again. And I also used this for looking at the differences in boroughs. So you can sort of see the differences in those distributions. And as was pointed out, if you do a test for the difference in the full distribution between weekends, so like a Kolmogorov-Smirnov test, for example, that will give you a significant p-value, which is the full distribution. There is a difference, but if you just do a parametric test for the difference in means, then we don't see a significant difference there. And so, which makes sense from what those plots look like. Since there are lots of outliers, we're going to see that there is a difference in the distribution, but there's not a difference under certain assumptions in the means. Okay, so then there's a package called this let's see, zip code R, which has some metadata by zip code. So it has basically some like census data by zip code. And so we merged that in. There's this reverse zip code function that will take a character vector of zip codes, and then it will give you a data frame of details about those zip codes. So I pulled out the zip codes that were not missing, and then I put them into this reverse zip code, and I got a warning. It said no data found for zip code 10,000. I think Shannon mentioned this, that she drew it on a nice map, and so I also sort of investigated what was going on with this this zip code 10,000, and it looks like these are all in Central Park. And so I went and quickly did a search for the couple that were missing and were able to figure out what they actually should be. And so I had made a little fix zips data frame that I merged in to be able to correct those. All right, so now the last part is the actual analysis. So for this, I'm going to use the Tidy Models package, the Broom package, and then I'm using this this DAL extra. This is a way to basically be able to sort of do some model explanation afterwards. So first, we just defined a variable over 3 hours, which was 1 if the duration is greater than 3 hours. And so I started by just looking at the distribution of this variable. Oops, pardon me, let me just do this real quick. And so when I looked at that, you can see that there's imbalance. It's not, we don't have a perfectly balanced group here, which is fine for any kind of prediction, but it does make you want to think about what kind of metrics you're using to evaluate that prediction model. So we have many more zeros than ones here. And so I then first built a logistic regression model. So I did this using the Tidy Models framework. And I did that because I knew I was going to be using the same kind of model for another, but with a different model type. So it sort of can save some time on the front end because I can set up basically my overall structure and then use some of that structure for future iterations of the models. So what I mean by some of this structure, for example, is like this cross-validation object. I can just create this once, and then I can use this for my different models. The way that Tidy Models works is that you create a model specification. So in this case, since I was doing logistic regression, I used this logistic reg function. If you have certain parameters you want to tune, you can identify them with this tune function. So here I decided to do a penalized regression, and so I tuned both the actual penalties, so like the lambda value for this model, as well as the mixture. So it would be like a ridge or lasso. And then I ran the model. Notably, I had a lot of natural splines. I put all of my continuous variables in as splines, which I think did improve. My logistic didn't look quite as bad as some of the others that have come out, but random forest did outperform it. And then I went ahead and ran this model. And so you can see the AUC here was 0.8, so not so bad, but some of the other metrics were not as impressive. And so I can look and see sort of which variables had the largest coefficients. These were all scaled beforehand, so I can compare these variables to each other since they are on the same scale. And it looks like maybe this community board X11 Manhattan was like a relatively large predictor. Then I can create this. There's a function explain tidy models that was in that DAL extra package, which lets me create this little explain object, which I can use when I'm making a comparison. So we're going to come back to that. I also fit a random forest, and this is where Tidy Models is kind of nice because all I had to do is just create this random forest specification, and then I could use the same workflow I created before, but just update that model to be my random forest model. And then I could tune that model and also pick the best, tune. So I picked this top one, which had an AUC of 0.83. And then I could fit that. And I also fit the little explainer for my random forest. And so I can look at different model performance. So first we can just look at the overall metrics. So for logistic, that logistic model had a recall of 0.14, precision of 0.64, F1.23, accuracy of 0.84, and AUC of 0.8. whereas the random forest was higher on basically all those metrics. So recall was 0.32, precision 0.72, F1 0.44, accuracy 0.86, and AUC 0.89, which is quite good. I could also plot those. So this is sort of a nice feature of that, of being able to use some of those explain functions, is that we can plot to sort of compare these. So here's like the comparison of the precision recall curves between these two models. And so random forest certainly outperforms here. And we can also look at like an AUC, a receiver operator curve here. And you can see that random forest also outperforms there. So that is what I have. I will stop sharing my screen, and then I think we can have some time for everyone to ask some questions to the group.
Yes, thank you so much, Lucy. Everyone give up your virtual applause for Lucy. Thank you so much.